RDS encryption is a critical component of database security in Amazon Web Services. It provides comprehensive protection for your data through multiple layers of security measures. Understanding how encryption works in RDS is essential for building secure and compliant database solutions. RDS encryption protects your database through two distinct mechanisms. First, it secures data at rest, which means all data stored on disk is encrypted. Second, it protects data in transit, encrypting information as it moves between your application and the database server. These two layers work together to provide comprehensive data protection throughout the entire data lifecycle. Encryption at rest uses AWS Key Management Service, or KMS, to encrypt your database storage. It employs AES 256 encryption, which is an industry-standard security algorithm. This encryption applies to your database storage volumes, snapshots, backups, and read replicas. However, there's an important limitation. Encryption must be enabled when you first create the database instance. You cannot enable encryption on an existing unencrypted database. If you need to encrypt an existing database, you must create a snapshot, restore it to a new encrypted instance, and then migrate to that new instance. When configuring encryption at rest, you have two key management options. The first is the AWS Managed Key, which is the default option. AWS automatically handles this key and manages its rotation for you, making it the simplest choice. The second option is a Customer Managed Key, which gives you complete control. With a Customer Managed Key, you can define your own rotation policies, set granular access permissions, and maintain full oversight of who can use the key and when. When you enable encryption at rest, it protects multiple components of your RDS infrastructure. Database storage volumes are encrypted, ensuring all data on disk is secure. Automated backups that RDS creates are also encrypted using the same key. Manual snapshots you create inherit the encryption settings. Additionally, any read replicas you create from an encrypted database are automatically encrypted as well, maintaining consistent security across your entire database infrastructure. Encryption in transit protects data as it moves between your application and the RDS database. This is accomplished using SSL or TLS protocols, which are secure communication standards. To enable this protection, your applications must use SSL certificates provided by AWS. These certificates establish an encrypted tunnel between the client and the database, preventing anyone from intercepting or reading the data as it travels across the network. You can configure your database to require encrypted connections by modifying database parameters. For MySQL and MariaDB, set the require_secure_transport parameter to 1. For PostgreSQL, set RDS.force_SSL to 1. For SQL Server, also set RDS.force_SSL to 1. Once these parameters are configured, the database will reject any connection attempts that don't use SSL or TLS encryption, ensuring all client connections are secure. Let's summarize the key concepts of RDS encryption. For encryption at rest, remember that it must be enabled during database creation and uses KMS with AES 256 encryption. For encryption in transit, SSL or TLS certificates encrypt the connection between clients and the database. Finally, you can enforce encryption by configuring specific database parameters that require all connections to use encrypted protocols. Together, these mechanisms provide comprehensive protection for your database infrastructure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.